All right, ladies and gentlemen, welcome to our first online lecture for Unit 4, where we will be talking about the periodic table and electrons. So today, just to make some connections for this unit, your book, we're going to have work coming from chapters 5, 6, and 7. Chapter 6 will be what today's work connects to. Of your objectives for the unit, we're going to focus in this lecture on the first four. So the first one deals with a lot of terms used to describe parts of the periodic table and how it's arranged. Also some of the names for different groups. You will be able to describe how we organize the modern periodic table. We'll classify elements based on their location as metals, nonmetals, or metalloids, and be able to talk about some of the typical properties for certain groups on the periodic table. Now for you as a student, the reason why it's important to you is that tool that you use on that test is one of the things that helps you do a good job on each assessment. And when we think about all the different types of matter that we study, the information that's located on this periodic table is valuable to us as we do our data analysis and make decisions. Before our current periodic table, trying to describe information and organize research was really difficult because no one sat down and looked at the elements and tried to organize them. Being able to communicate was very difficult. Think about going to the grocery store and wanting to get a certain substance. You want to go get some cheese, you want to go get some chips. Because the store has an organization, you know where to go to find those things. In chemistry, we had nothing like that. And the first step in our process to creating ones came with John Newlands and something called the law of octaves. Now, the law of octaves from Newlands essentially looked at some patterns related to sets of 8. So octaves should make you think like an octopus having 8 tentacles. And one of the first people to start researching and doing some investigations of that was Dmitri Mendeleev. When he decided to arrange them, he looked at atomic weight as a valuable property to be able to organize them. So first he arranged them all in rows by increasing atomic weight and then put them in columns based on how they reacted. What he noticed is that sometimes to keep his pattern, he had to leave some blank spaces, and so he did that for some undiscovered elements, and later on those elements were found to be existing. So he was able to correctly predict these unknown elements. He also noticed that sometimes in order to keep the reactivity patterns, he had to switch the atomic weights. So that pattern wasn't the actual way they were organized, but it was the best he could do at the time. He noticed that his columns and row arrangements supported this law of octaves or pattern of 8. So today, when we look at our periodic table, while the atomic mass is pretty close to being continuously increasing, Henry Moseley noticed that it's actually better to do it by atomic number. So in his research, he was able to see that the atomic number was consistent when we arrange them in this setup. A horizontal row is called a period because it repeats in the same way that a periodical is a magazine that you get on a repeating basis. The columns are called groups or sometimes families, and there are a couple different numbering systems that work. When we number them straight through, we go 1 to 18. Some of the numbering systems will also use Roman numerals and then either an A or a B to describe some of the groups on the periodic table. So, to match Mendeleev's pattern, we see that elements in the same group, which is the column, share a lot of chemical and physical properties. He did that to try to create some organization. What we've now discovered is that they have the same number of valence electrons. Those are the electrons in the furthest location from the nucleus. And that type of valence electrons will help determine what kind of ions they form. So largely what we see is that the number of electrons are really what's determining how they behave and give them those chemical and physical properties. Some of the families include more than one column. It might be only one column, but what makes them a family is that shared set of properties. So what we're going to go through next is some of those typical properties that are true for certain groups on the periodic table. Now, hydrogen is kind of a unique element, and you'll remember that when we did our POGL earlier in the year, we pointed out that hydrogen is a nonmetal that is at the top of a column of metals. It is a gas and it's a nonmetal. It is diatomic, and that's a term that means that it exists as two of the same atoms bonded together. Remember, that would make it a molecule, but it's still an element. Hydrogen was involved in the explosion of the Hindenburg. It was a large blimp-like structure, and the lifting gas they used was hydrogen. Unfortunately, when you have very explosive gases and you have the risk of fire, it didn't end well because it set on fire when they had a problem and it had the blimp fall. When we take a look at hydrogen, it is something that we are looking at to be possible fuel sources for automobiles, but there's a lot of work that still needs to be done to make it safe to use. Now, again, this picture helps us see a little bit more on the table, the label of a group or family. So an individual column would be a group, and a period would be a single row across the periodic table. Notice that there's a gap here. We would only count the ones that are actually in the row into that particular period. Now the first column on your periodic table is called the alkali metals. Remember that this group does not include hydrogen. This is a very reactive set of metals, so reactive that it typically exists as a compound. Think like sodium chloride. Sodium is an alkali metal. When we have pure forms of these metals, they're very soft. You can cut it with a knife. And they tend to have to be stored in mineral oil because they will react with water vapor in the air. The second column is the alkaline earth metal group. These ones are also very reactive, but not as much as the first column. They still tend to be combined in compounds when found in nature. We do see a lot of these types of elements as being some of our dietary needs. Magnesium and calcium help serve biological purposes within us to help our bodies function correctly. Transition metals are that entire group that is slightly set down from the first two and the last six groups. They're less reactive and they're quite hard, and that makes them very useful in construction and in jewelry. So these types of metals will hold up over time and do not react or break down as easily, and that is why they're so good at these particular uses. So again, like I said, these transition metals are in that section that is kind of set down. The boron family, a couple of the groups are known mainly by the element at the top of the group. This group has some metals and some non-metal type ones because it's starting to get into that section with that staircase. Aluminum, it is kind of interesting, used to be rare. Now we use it in tons of different things and it's very accessible, but it used to be very expensive in the way that we think of jewelry types of metals. The carbon family is one of the most important in terms of biology. There's an entire branch of chemistry based on studying carbon because it is able to bond to 4 different atoms. This makes it much more likely to create large structures, and so a lot of carbon-based compounds have a lot of unique properties. Within the same group, silicon and germanium are important semiconductors, so they're found in a lot of electronics. The nitrogen family connects very much to the atmosphere. Nitrogen is actually the most abundant gas in the atmosphere. Nitrogen and phosphorus are very important in living molecules. So a lot of our biological molecules include those elements. Interestingly enough, most of the nitrogen in the atmosphere is not available to living things as N2, so we depend on bacteria to be able to transform and modify that to bring it into the different cycles of matter. The oxygen family is getting into some fairly reactive types of elements. Many things that kind of stink would be in groups like this. Sulfur compounds would fit here. This is that rotten egg smell. And the oxygen being reactive is related to how it helps the respiration process and cell respiration. The halogen group is the name for the group that is right next to the second, or is the second to last column, right next to the noble gases. It is very reactive. These types of elements, again, like those alkali and alkaline earth metals, tend to be combined as compounds, but they can be found by themselves more often than those metals. Many of these are used as disinfectants. We think of like fluoride for our teeth, and so because of that toxic nature, they can be helpful in that way. Lastly, we have our noble gases, the far right column on the periodic table. The reason they are called noble is that they don't tend to react with anything else. They are very stable. They are gases that the particles tend to be single atoms as opposed to diatomic, like we mentioned with the hydrogen. When we think of neon signs, when we run electricity through these gases, it will cause that glowing. Believe it or not, neon specifically makes red, but any type of sign like that that isn't red is probably not neon gas. It's typically going to be something else. You see in the diagram up in the top right some examples of the emission of light from some of the different types of gases. These, because they are so stable, tend to be used in blimps because they're not going to react or be flammable. And in terms of valence electrons, they have a full set. This is largely why they don't react. They don't need to change in any way to become stable. The next task that we're going to take a look at is classifying elements based on many of their properties. We're going to be doing a lab where we're going to compare some of the properties of metals and nonmetals and look for patterns to see what's typical for each kind. We'll be able to look at some of the descriptive physical properties. We'll study conductivity. We'll look at malleability, which we mentioned earlier is that ability to be hammered or kind of bendability. We'll look at reactivity with two different types of compounds. And we'll look at what happens when we add energy to those particular compounds, elements. So now that we understand that the periodic table is arranged in terms of atomic number and is going to have elements with similar properties in the same groups, we're going to explore and observe some of those properties for a specific set of elements.